Alright guys, so we've already done these lessons, and I just want to go over them with you guys because I want to go back and make sure that we completely understand this, because it seems like we kind of rushed through it back when we were in school a month ago. And like you guys know, I have a YouTube channel for all of this. You guys should go find it. It's just my name, and it has the green icon that you guys see when I email you. So, like always, go like and subscribe to these videos and subscribe to my channel. It's great. It's where you guys will see the videos first, unless you guys see them through Google Classroom. So, lesson 30, Trig and Pythagorean Theorem. So, in a right triangle with an acute angle measure theta, the sine of theta is 1/2. We need to find the value of the cosine. So, we're going to draw a diagram. So, we have this right triangle right here. And that's terrible, so I'm going to use draw to shape, or ink to shape. So, the sine of theta. So let's call this angle right here theta. Is 1/2. So that's 1. That's 2. Now let's use Pythagorean theorem to solve this. We're going to get 2 squared is equal to 1 squared plus b squared. We'll call that b. Okay. So 4 is equal to 1 plus b squared. Subtract 1 from both sides. 3 equals b squared. And then we just take the square root to solve for b. So b is equal to the square root of 3. So the cosine of theta is equal to adjacent over hypotenuse, so that's square root of 3 divided by 2. And that's all we had to do. In a right triangle with an acute angle measure of theta, the sine of theta is 7/9. So we'll call this theta. This is 7. That's 9. What's the value of the tangent of theta? Okay, well, let's solve this. 9 squared is equal to 7 squared plus b squared. So 81 equals 49 plus b squared. Subtract 49 from both sides, and we're going to get 32 is equal to b squared. Take the square root, and we're going to get that this, we can break it up into square root of 16 times the square root of 2 is equal to b, which gets us 4 square root of 2 equals b. So now, the tangent is our opposite over our adjacent. So the tangent of theta is going to equal 7 over 4 root 2. Now, we may not have to rationalize, but let's rationalize this. Let's multiply the top and bottom by the square root of 2. So we get 7 root 2 over 8. And that's our tangent of theta. Both of these. I'll accept either one on a test. Both of these are going to be right answers. So we have 7 over 4 square root of 2, or 7 square root 2 over 8. Now, these are going to be the exact same thing when you put them into decimals. I'm just making it a little bit easier on us. So, what common right triangle was probably modeled in the construction of the triangle in Figure 2? Use sine of 53 is equal to 0.8. Now, if you guys remember, we talked about the history of this, and they were using this to build the Great Pyramids. So, this angle measure, it's not truly 53. I think we figured it out to be like 53 point something. But it's just easier to write 53 degrees. So let's take this triangle out of there. 53, that's our right angle. Now, if the sine is 0.8, that means that 0.8, written as a fraction, is 8/10 or 4/5. So that's 4, and that's 5. So, to solve for b, we're going to get 5 squared. That's a terrible 5. 5 squared equals 4 squared plus b squared. So 20, why did that 2 change to a circle? 25 equals 16 plus b squared. So 9 equals b squared. Okay, so let's take the square root. We're going to get that 3 is equal to b. So this is a special right triangle called a 3, 4, 5 right triangle. These are the ratios that they use to build those pyramids. So the actual angle between the base and the lateral faces of the pyramid is actually closer to 52. Considering the age, what could account for the difference between the angle measure in A and the actual? So, what could account for this difference, guys? Well, if we're looking at this, there's a lot that could account for this. We could say that they probably weren't using accurate measurements. We could say that they were just doing this based off of the base and the height. So for every 3 they went in, they went up 4. So for every 3 feet they went in, they went up 4 feet. Every 3 meters they went in, they went up 4 meters. Something like that to account for this. And this just naturally happened. That it happened to be a 5 right there because of Pythagorean theorem. So why do you think architects choose to use the 3, 4, 5 as a model for the triangle? Now, they could use the 3, 4, 5 because it works so perfectly. As soon as we have something like this, a 3, 4, 5, it could be a 6, 8, 10. It can be a 12, 16, 20. It can be a 9, 12, 15. Anything that follows these, even if they're decimals, will always be a scale version of the 3, 4, 5 triangle. That's why architects choose to use this. Now, let's see why tangent of theta is sine of theta over the cosine of theta. Well, sine of theta, if you remember right, the sine is always going to be our opposite over our hypotenuse. So we're going to get A over C. And the cosine is our adjacent over our hypotenuse, so B over C. So if we divide these two, we'll get A over C divided by B over C. And if we divide a fraction by a fraction, what we're going to do is we're going to take that fraction in the denominator, flip it, and then multiply those two together. So we'll get A divided by C times C divided by B. And because we have these two C's opposite of each other, one in the numerator, one in the denominator, we get rid of them. So we get A over B, which is our tangent of theta. Now, guys, after this, go ahead, take a break. You guys have earned it. We've done a lot so far. And if you guys need to, take breaks throughout these videos. I know they're kind of longer. Take a break. Go get something to eat. Go get something to drink. Go for a run. Go walk outside. Get some sun. Do what you guys need to do to stay sane throughout these videos, because I know it can be pretty rough. And especially with the distractions at home, I know it's rough trying to get through these. So, now that you guys are back, in a right triangle with acute angles of measure theta, the sine of theta is 1/2. So we already did this, guys. We did exercise 3 and 4 back up here in exercise 1 and 2. Alright, we used our Pythagorean theorem to find that. So we're going to skip 3 and 4. And we're going to do our problem set. So the cosine of theta is 4/5. So we're going to draw out this. Oh, I don't have any shape on anymore. We're going to draw out this triangle. 4, 5. That's our theta. We need to find the sine of theta and the tangent of theta. So let's call this side A. So you're going to get 25 squared. Or sorry, not 25 squared. 5 squared is equal to 4 squared plus A squared. 25 is equal to 16 plus A squared. 9 equals A squared. A equals 3. So now the sine is our opposite over our hypotenuse. So we're going to get 3/5. And our tangent is our opposite over our adjacent. So that's 3/4. I'm going to leave the rest for you guys to do of those 4 problems there. So we need to find the missing side length here using sine, cosine, and or tangent and round to 4 decimal places. So we need to find our hypotenuse, and we need to find our opposite leg to this 27. So what I'm going to do is I'm going to use the tangent of 27. So that's equal to our opposite of x divided by our adjacent of 12. Now, do you guys see how I set that up perfectly to be a super easy calculation to do? I know that in tangent, we're going to have to end up multiplying by our adjacent side. So I set it up in a way where I can multiply by the adjacent side and get our number. So we're going to get 12 tangent of 27 is equal to x. Now, I don't know what 12 tangent 27 is off the top of my head. I don't expect you guys to. I don't expect anybody to know what the tangent of 27 is off the top of their head. But I want you guys to use your calculators for this. So our x is equal to 6.1143 units. Now, we're not given units, so I'm just going to write units out. Now, we're going to do almost the same thing for y. So we're going to use, let's use 63. So let's say the sine of 63 is equal to our opposite side divided by our hypotenuse of y. Now, there was no way I could set this up to easily be able to find that y by multiplying once. So what we're going to have to do is multiply both sides by y. So we get y sine of 63. Well, y sine of 63, that's because that's how we set this up. And I know you guys missed my puns. So we're going to divide both sides by the sine of 63. So y is equal to 12 divided by the sine of 63 degrees. Now, like I said before, I don't expect you guys to know these off the top of your head. So we're going to go 63 sine times, divided by, nope, I messed that up on my calculator. 12 divided by the sine of 63, 13.4679. Now, I'm going to leave the rest of these problems for you guys to do. We're just using sine and cosine for now. Okay? We're using sine and cosine to find these. So, finding the height of the pyramid to the nearest tenth, you guys are going to use cosine here to find that height. Given a hypotenuse of 9. So, find the height, use sine. If you're going to find the base, which we'll call b, you guys are going to use cosine there. And then you're going to find the lateral surface area of the right triangle pyramid. Now, what that means is that once you find this base, okay, that gives you half of this base area here of this triangle. So that's going to be b. This is going to be b. So the whole area is 2b for that base. And this length right here is 9. So you're going to use your formula for area of a triangle, which is base times height divided by 2. Find the area of one triangle, multiply by 4 to find the area of all of the triangles, and then find the area of this base square, and you'll find the surface area of the right rectangular pyramid. Now, I feel like you guys can do these. I know you guys can do these. So I'm going to leave the rest of these for you guys to do. And like I said, the easiest way to see this video is to go to YouTube, subscribe to my channel, and you guys should turn on notifications so you can see when I post new videos. Check it out on the Google Classroom. Any of those ways that you guys see this video, I just want you guys to see it, and I want you guys to be taking down notes. I did put Word documents in this time so that you guys can edit them a little bit if you want to. I would recommend getting a notebook, or if you guys have a blank notebook at home, just writing this down in there instead of writing it down on, or printing out and writing it down on that. Your notebook will be immensely helpful over the rest of the school year. You guys will be able to use notes on every single test, every single quiz. I care more about you guys I care about you guys learning, yes. But I also care about you guys staying sane during this time and you guys being healthy, okay? So don't take too much time going through these videos and writing down your notes. And use your notes on tests and quizzes and homework. it'll cut down the time you guys take on those. All right.